in like all languages. What time is it? It has a mathematical word. I mean, it has a mathematical meaning too. Of course it does. Of course, of course. Finite sequence or ordered list of numbers, which are called the elements. Wow.
N_sweep says that makes sense.
Oh.
They are immutable because they are ordered sequences.
Oh. That kind of makes me wonder if then wouldn't that mean tuples in C# should also be immutable if it's like math, if that's what it means mathematically in C#? Immutable? Yeah. It's like, I guess that's what makes something tuple E. Finite sequence order list. That's good. That's cool. Okay. Multiple elements from tuple. The set is unpacked and each element is added. Sets. I mean, why would you... I guess I see. I don't know. Like, what's the purpose of this? I mean, maybe this isn't the best exam. Oh, wait. Oh, this is not... They're making a list out of something that's not a list. So I guess that's the point of list, is like, make this list. But what is... The brackets are sets? I think you said... Well, yeah, it's not a dictionary, so it has to be a set. And then you said sets just have individual
N_sweep
values.
says that's a set, yes.
So what makes sets special from lists? Because I assume both are mutable. Because tuples at least are immutable, so that makes them special from... Oh yeah, you said that! Oh my god, I failed! I failed the quiz! Unique values. Python needs names, different names for these things. Like, how about calling them instead of set?
N_sweep says that's okay, LUL.
Okay, call them, unilists, which stands for unique value lists, or UV lists.
N_sweep says set is a mathematical concept too.
So in mathematics, a set also can't have duplicate values, which maybe that's why they use it. Oh, see, if I just knew more math, Python would be easier. Okay, I see. No wonder.
N_sweep says yep.
No wonder mathematicians and people, from math disciplines love this language so much because they already like understand what everything is. They're like, just by seeing the names of things, like, yes, this just inherently makes sense. And then they don't need to read the English because they just can like understand the concepts because it's math. See some example code and they're like, yes, that makes sense, because that's the English is so bad.
N_sweep says they love it because they don't have to learn about type safety.
But type safety is literally the best feature ever, and I love type safety so much. I miss my type safety. And if there was just like a command to Python to like turn it back on, I would give to turn on the type safety. I feel so just unsafe. Every time I work with Python, I just feel so unsafe. Multiple elements from set. Results when using a list constructor with a string or a dict may be surprising. See? Maybe surprising is a polite way to say cursed. Curse. Use Python aren't
N
software developers
underscore
in the
sweep
same
says the
way.
scientific folk who use Python aren't software developers in the same way.
I see. A notebook that is exploring some
N
data.
underscore sweep says imagine writing a notebook that is exploring some data that will be run one time and having to be specific about every type.
Oh. Like a short program, not like a huge game that you spend like 20 years on adding new classes to. That if one thing goes wrong, your whole game will
N
break.
underscore sweep says notebook as
Oh,
in Jupyter notebook, if you're
I
not
have heard of
familiar.
that before, and people have said that's like a huge like plus side of Python. Like that's one of the things that people really like about Python. I thought it, and I was guessing it was something like that makes it easy to write code and share it with people or something.
N underscore sweep
Type
says yes,
hinting.
when I build a big piece of software that will be reused, I use type hinting.
Oh. So that's what data analysis is like? It's like a piece of code that you just run like once or twice. Or, like it's like a self contained thing. That's not super big. The string or a dict may be surprising. Oh god, string elements. Unicode code points are iterated through and added individually. Multiple elements. String equals list. Hey, there's an example of a string. What, remember you said that the strings can be treated like lists? It's doing that. That's cool. Jupyter Notebooks allows you to write a bunch of small snippets of code and run them
N
separately from
underscore
each
sweep
other.
says yes, sort of.
Oh wow.
Jupyter notebooks allow you write a bunch of small snippets of code and run them separately from each
Hmm.
other, but in the same environment.
Is this something that's supposed to run on your computer, or is this something that's run on someone else's server? It's like a service. Like, yeah, like like a cloud service or something. Unicode separators and positioning code points are also added individually. Multiple code point string.
N underscore sweep says both. It's an open source local tech, but people provide it as a service too.
That's what Google Collab is? I didn't know that. It's just Jupyter Notebook.
N underscore sweep says yes.
Oh wow. But Google Collab, that's not just exclusively Python, right? Oh, good for googly skin on it.
N underscore sweep says it's Jupyter with a Google Y skin on it.
Jupyter Google Book. Nice. Hmm. So is Jupyter Notebooks not language specific? Oh, Julia, Python, R. Oh.
N underscore sweep says Jupyter is
Jupyter.
called Jupyter because it's for Julia, Python, and R.
Oh, that's why it's spelled so weird. It's cool. Google missed out on calling it Jupit Gore because so that Google can be in there too. Jupit Gore. Mhm.
N underscore sweep
I
says
know. I'm a
LUL.
genius. The stomp would go up so much. Or maybe actually, even maybe just have the double goo so it's more clear that Google is like more important than Julia, more important than Python, more important than R, so that it will have 3 letters, and then it can be Jupyter for Google, Jupyter, and then yeah. Or just you're right, G with the G and run
N_sweep says
Jupiter.
Jupiter.
That's a good one. That's good too. That's. I can't believe they didn't do that. That would. It looks perfect. See, they should hire you instead on their marketing team. Who could just knock Julia off?
N_sweep says Jupiter. Who cares about Julia anyway?
But then Google might be in hot water for, oh, they're sexist for knocking off Julia. The iteration default for the dictionaries is over the keys. So only key data is inserted into the list.
N_sweep says Julia is supposed to be awesome. I want to learn it LUL.
Oh, cool. I've very infrequently heard about Julia, and I don't even know what it's used for. So, yeah. Iteration, where was I? Default for dictionaries is over the keys, so only key data is inserted into the list. Fish, skull, monkey, brown.
N_sweep says it's used in the math and science space from what I understand.
Oh, these are the keys. Fish, monkey. Oh, fast. Oh, I like that. Oh, so it's like Python. If Python didn't suck and wasn't slow, it's like, yay. But also loved by the math and science people. Oh.
N_sweep says yeah, I guess the syntax isn't as friendly.
Yeah. I mean, I wouldn't be surprised.
N_sweep says I don't know the history.
I wouldn't be surprised if it's just because Python got there first. I feel like a lot of things that we have that are popular are just popular because whoever gets there first, ends up dominating, and then all the stuff is, built on that, and then people don't want to have to remake everything, so everyone just sticks with it, even if it's not as good. Because the list constructor will only take iterables or nothing as arguments, objects that are not iterable will throw a type error. Oh my god! It's finally something that actually throws a type error in Python. Amazing. Consequently, it is much easier to create a one-item list via the literal method. Oh yeah. Numbers are not iterable, and so attempting to create a list with a number passed to the constructor fails. Oh wow. Not iterable. Tuples are iterable, so passing a one-element tuple to the constructor does work, but it's awkward.
N_sweep says I love Python's forced indentation because it ensures others write their code legibly for me to read LUL.
I see. one element tuple to the constructor does work. I like how it just says, but it's awkward. No, this is the proper way. Proper way is just to accept the cursedness, give into it. Do more of it. Accessing elements. Items inside lists as well as items in other sequence types, string and tuple.
N_sweep says that's what I was talking about
Oh,
earlier
they're
with
doing
tuples
that.
of single values.
But then you're just like, oh yeah, but it's awkward. It's just like pointed out. Cool. Items side list equals items and other sequence types, string and tuple can be accessed via zero base index and bracket notation.
N_sweep says you can inadvertently create one without the if you leave a comma on the end of something where it shouldn't be.
Really? Like an accidental tuple? Oh, okay. Interesting.
N_sweep says there's a good reason for that, but don't worry about it, RN.
Yeah, I wouldn't be surprised if it's some kind of like shorthand or something, like to make programmers' lives more convenient or something. But that's interesting. It's good to know. Indexes can be from left to right, starting at 0, or right to left, starting at -1.
N_sweep says yeah, pretty much.
Okay. Python. Breakfast foods. Oatmeal, fruit salad, eggs, toast. Oatmeal is at index 0, index -4. Yeah. Breakfast foods, -4. Eggs are index -2 or 2. Toast is at -1. A section of the elements inside a list can be accessed via slice notation. A slice is defined as an element sequence at position index such that index start is less than or equal to index. Wait, is this actually like less than equal? I think less than stop. Start is less than or equal to index. I guess that makes sense because it can't be below where it starts. Less than stop. Oh yeah, right. So and then you can't go above where you stop. Slicing returns a copy of the sliced items and does not modify the original list. Oh, okay, you get a copy. Okay, interesting. A step parameter can also be used. Start, stop, step. To skip over or filter the list elements. For example, a step of 2 will select every other element in the range. Oh yeah. Red, purple, green, yellow, orange. If there is no stop parameter, the step is assumed to be 1. Colors. This is start on 2. And skips. Start. Oh, this is stop. 3, 4, 5, 6. Wait. 2, 3, 4, 5, 6. I think I can't count. 1, 2, 3, 4, 5. Shouldn't it stop at
N underscore sweep says start at 0.
Start at 0. Like over here in 0? 0, 1, 2? Like, oh, it just says middle. Oh yeah, middle colors, yeah.
N underscore sweep says you counted red as 1.
Oh, no, I meant, it starts here, like 0, 1, 2. And then 3, 4, 5, 6. Oh yeah, I forgot. Stop cuts out. That's what it was. Where you stop, it cuts it out. It doesn't, it's not. Oh yeah, it's exclusive, not inclusive. I see. You know, that really throws me off. That's so annoying.
Underscore sweep says, yeah, you got it.
I hate how functions in different languages, like sometimes they're inclusive and it includes the stopping point or whatever, and then sometimes in other languages they're exclusive. It's just like, how am I supposed to know? Okay.
N underscore sweep says yes, left inclusive.
This is
right
the
exclusive.
only way. All other ways are wrong. Oh my god. I guess this is why people use IDEs, where you can like hover your mouse over the method and it will just tell you if it's like inclusive or exclusive. And now I see, because it's inconvenient, especially if you're using like multiple languages, trying to remember like what things, like the exact specifics. If the start or stop parameters are omitted, the slice will start at index 0.
N underscore sweep says there's a Python package called pandas that is used for data analysis.
That's what pandas
so
is.
I'm using it every day.
Oh, cool. Oh, defaults to left inclusive,
N underscore
right
sweep
inclusive.
says it has one method that defaults to left exclusive
2
and
hours
right
just
inclusive.
from that. Oh no.
I lost like 2 hours on this one day.
Oh no. Inclusive, because you're so not used to see having things switched around. This is confusing.
N underscore sweep says I'll never forget it. LUL.
Pandas.cut. Wow. So that's what pandas is. For a second, I thought it was like another language. When I saw it listed like separately from Python. I think I saw it listed once. Like it was like Python 2, Python 3, and then pandas. So I was like, I think I thought it was like another another programming language. Nope, just a package. Alright, primary colors. So skip 3.
N underscore sweep says it's a big enough package that people want to know someone is familiar with it.
Oh. That's why it was listed by itself, because there's just so much. Oh, wow. I see. Working with lists. The usage of the built-in sum function on a list will return the sum of all the numbers in the list. Sum number list 10. Okay. You can also get the length of a list by using the length function. Oh, nice. List. But this will give you the number not starting from 0, right? 1, 2, 3,
N underscore sweep says you
6,
likely
7,
won't
8,
have
9,
much
10,
occasion for it going into games, but if you ever have to manipulate a data set, keep pandas in mind.
Okay. So it's especially good at that and saves time when it comes to data sets, manipulating data sets. Let's see. It might sound crazy, but to a certain degree, I don't want to do anything crazy like make a big game. But if I have enough in the future, if I have enough Python knowledge to make a game, then I definitely want to make a few small things. Simply because if you can make a game run in Python, I'm pretty sure you can make it run in any language that's not Python because it's so bad. Like if I can make graphics or, make things not really sluggish and somewhat interesting, then I'll feel good about myself. It's like, hey, I did this in Python of all languages. I can definitely do this in, C sharp. Ah, Conway's game. But did you program Doom? Did you do it? Did you do it?
The war game I described earlier, and Conway's game of life.
That's the bar. Certainly not. You need Doom.
N_sweep says certainly not LUL.
But yeah. This can be also combined in various ways. I heard too that Python is used in many cases. Like, it's popular, but it's often used as just a wrapper because of its like performance. But it's easy to work with, so people like it as a wrapper.
N_sweep says Conway's is a great project. I highly recommend that for later when you've completed all this stuff.
Heck yes. Let's see. Alright, I'll take a note of that too. Conway's. Cool.
N_sweep says you can find the rules on Wikipedia.
This can be also combined in various ways. Using the plus operator unpacks each list and creates a new list, but it is not efficient. Movie concatenate. George. Got Tabby. Okay. Likewise, using the multiplication operator is the equivalent of using plus n times. Cat, dog, elephant. Cat, dog, elephant, cat, dog, elephant. Oh, this is kind of a cool feature. Lists supply an iterator and can be looped through / over in the same manner as other sequence types. Looping through the list and printing out each element. 4 item in colors. Print item. Green, gray, blue. It is really interesting that that lists can like iterate themselves like that. Because I remember when I was first working. Well, when I first met you and you came in and then you told me to use the print statement to see what I get, and it printed out everything in the list. But then again, I did just, well, I don't know. I guess it's not really iterating per se. It's just printing the list.
N_sweep says the for x in y statement is doing the iterating.
Yeah. I'm like thinking about what this would look like in other languages. But I think you would literally have to just get the length and then have to like do it that many times. You couldn't just do in whatever the thing is. Very Python-y. Loops and iterators complete the loops concept. Okay. Instructions. Here. Oh.
N_sweep says yeah, like for I in range, len, list, print, list I.
Oh my god, that's the Python way to do that? For I in range. Oh my god. Main list. Though I'm kind of surprised you have to do for eye and range, and you can't just say for eye and length list.
N_sweep says len just returns an integer, range takes it in and creates a list from 0 to that integer.
So you're just taking the list and then making another list out of it? Why? You just might undo. Why? That seems so excessive. No! Don't take them out of the list and then put them in another list, but just integers this time.
Essentially LUL.
Oh, this one. Yeah. This is why Python is so inefficient. Because, what is this? Lisa's really looking forward to playing some poker and other card games during her upcoming trip to Vegas. Being a big fan of self-tracking, she wants to put together some small functions that will help her with tracking tasks and has asked for your help thinking them through. Okay. I wonder if we're gonna code any functions that tell her, like, how much money she's losing and when she should stop, because that's what I'm thinking of right now. Like, this is a bad idea. Implement a function.
N_sweep says ha 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 ha.
No, I might not be a data scientist or mathematician, but, you know. Yeah. I won't fall for the gambler's fallacy.
N_sweep says I'm not either. I never gamble.
Nice. Okay, yeah, it would be a little concerning though if you were like a data scientist and spend time with numbers and gamble a lot. It's one of those things maybe that's not good to put on a resume. Unless that, yeah. But then you'll just end up being.
Says, I mean, if I could leverage the statistics in my favor, LUL.
But then you'll just end up being on like a hit list or something, and kicked out of every casino ever.
N_sweep says I'm a lot stronger of a programmer than statistician though.
And the worst part is, here's what I heard. I watched a video, and apparently there's this card counter guy who's like well known. But he basically like can't do anything anymore. Like he has a whole YouTube channel like based around it, and like every single like major casino, like they all are using AI facial recognition. So even with disguises, you know, they get you with it. So yeah, the world has changed. Brutal, I know. See?
N_sweep says brutal.
Yeah. See, so if you did that, if you leveraged your mathy prowess and tipped the odds in your favor, then you would end up being foiled by the very thing you work with. The AI would catch you. The irony. Elise is especially fond of poker and wants to track how many rounds she plays and which rounds those are. Every round has its own number, and every table shows the round number currently being played. Elise chooses a table and sits down to play her first round. She plans on playing 3 rounds. Implement a function get rounds, round number, that takes the current round number and returns a single list with that round and the next 2 that are coming up. Okay. Give me Python. Of course, the next one's list methods, like more lists, and tuples, and then dictionaries, because lists everywhere, list-like things, and then sets, and then dictionary methods. Okay, everything is like 90% of this tree is probably just like things related to these particular things. This will be fun. This seems really interesting. This concept. Generators. This. Okay. So, let's see. Hmm. Like this, I feel like the way I'm gonna do this is gonna be like inefficient, but and not like the optimal way you're supposed to do this, but whatever. Um, let's do that. Wait a second. If Python is passed by reference, isn't it? Is it? Oh, let's see. Not passed by value. I wonder what this will do. Oh no. Invalid decimal literal. Wait, int current number. Wait, I can't add an int and an int? This is like, what's happening? Why can't I do this?
N_sweep says this is a weird error.
This is weird error. This is weird. Um. Do oh. That's weird.
N_sweep says I've seen lots of Python errors and I'm not terribly familiar with this one.
If a decimal. Python is cursed. So you think this code should run, right? In theory, what I wrote, it doesn't seem wrong, right? I just wanted to add a number.
It's coming from Exorcism's internal tools.
Oh, something related to, okay, the implementation. That's so weird. Cursed. All I have to say.
N_sweep says you can add ints to floats too.
Yeah. Yeah, that's true. Yeah. This isn't fair. Maybe it's related to my print statement. Because of what exorcism is doing. Okay, no, never mind. Okay. What if I just delete it a second?
N_sweep says no, it's happening on line 13.
Yeah. But when I deleted this, and it was fine with that. What if I name it like this? What if it's because I put a 2? It's because I put a number 2 in the name. In the name of the variable. It's weird. Oh, I can't. Oh. Oh, I didn't. Okay. Okay. Fine.
N_sweep says
I'm
you can
sad.
put them elsewhere inside though.
Elsewhere inside. Oh, but just not at the beginning? That's a dumb rule. Okay, I'll just accept it. Sorry. Oh wait, no, I need to.
N_sweep says like number 2.
Number 2. Okay. Let's see, what did I print? Okay. Nice. So that's what I wanted it to do. So it number. So what does that mean? Doesn't that mean this is? Oh wait, no. Pass by reference, pass by value. That's something different. That's a completely different thing. Concept. Okay.
N_sweep says number has not changed.
Yeah, you're right. It didn't. I guess I was thinking of like um what's an example? I don't even know. Like wait, give me a second to think. If you
N_sweep says if you passed in a list and changed that list inside, the list outside would change.
Oh, that's the thing. That's what it is. Yeah. Yeah, pass by reference. I think. Um
N_sweep says yes, you're right.
the copy. I see. Sure. And then I just put them all into a list. I guess I can just do like. Can I do this? Third. What did I return? Wait, I returned 3 things. Oh wait, because I did return a list. And that was supposed to do?
N_sweep says you want item, item, item.
Oh, that breaks things into a list. Oh. Okay. Wasn't there like a. No, wait, that was for strings. The dot join thing was for strings. I mean. Could I wonder if I had.
N_sweep says you
A
were
special
right.
word.
Just change it to square brackets.
Yeah, could do that. I was also kind of wondering too now, if I had put this, if I could have made this into a list with one item, then maybe I could have used like the append to like keep putting new ones onto the list. Maybe that also would have worked too. Kind of want to try doing that if that's valid, because it seems more fun than just like putting them directly into a list with the brackets. What should I call it? Oh yeah, you name things like this.
N_sweep says yeah you can do that, but your starter list should be a literal 2 instead of using the list. function.
Okay, I see. You still need to start with literal. Actually, maybe, yeah. Okay. I'll make an empty list, and maybe I can do something that looks more interesting. Like a loop that increments it 3 times. It's kind of unnecessary, but like increments it 3 times, and then it like adds them into the list. I used one last time. I don't remember what I did for. Um. Hmm. Okay. I've used for X and Y, but I wonder if I can just do like for. Oh wait, no. You sent me. Let me look at what you wrote, because remember earlier
N
you sent me an
underscore sweep says
example
that will
of
also work.
counting.
TBF though they haven't put you through loops yet.
Yeah, they haven't, but I used a loop that other time, so why not now? That's what I say. Better prepare for the future. Then the loop exercise will be super easy.
N underscore sweep says yeah you want the range function.
Oh, then I would use range, but range takes a list as input, doesn't it? Or can I? Like I can't just say for.
N underscore sweep says no, an integer.
Yeah, I could just. Yeah, I wanted to use like an integer, like in. Let's see. Where's what I was looking at in this video? I mean, do you have your own variation of this?
If you want your own function,
The I equals 0, I less than. I wanted to do one of these. Let's see.
N underscore sweep says do you have somewhere outside of the exorcism space to write and test code?
Oh, yeah. Oh, that's what. Oh, that takes an integer. That's what you were saying. That's what range is for. Oh, wow, that's different. For I in range. Python's so weird. I do. And you know what? I just remembered J. There's a site called JDoodle, and it lets you write code, and you can like invite someone to like write code with you in real time. Like I just remembered because I just learned about it the other day. Oh, REPL has a feature too. Cool.
N underscore sweep says replace.it is another one.
Oh yeah, I have used REPL before, but it's very like there's a lot of features, like so many bells and whistles. It's kind of overwhelming. Yeah, there were just like so many like things. I was like, oh my god. Also, I don't know if REPL needs an account.
Says, yes, I agree.
I have an account though, but JDoodle you don't need an account. It's very like bland. You just write.
N underscore sweep says if the one you suggested is newer, it might be less overwhelming.
I think JDoodle has been around for a long time, maybe even before REPL. But because a friend introduced me to JDoodle, but it's like has pretty bad performance, or it used to be really good, but then they like did an overhaul of the site with modern web design, and now it's like bad performing.
N underscore sweep says interesting. I've never heard of it.
Yeah, I don't know if they have Python. I just know they have C#, I think, and like assembly and C++. Modern, it destroyed the site. And
N underscore sweep says modern web design LUL.
And it was like my friend's favorite site, but now it's like now they call it Jankdoodle. But it seems fine to me. Like I just started using it like the other day, and it seemed fine. But it was a little slow, but not slower than any other modern designed website, so it didn't really bother me.
N underscore sweep says
Why?
people are always surprised
Yeah, why
when I
fix
don't do
things
web
when
stuff.
they're not broken? But so it can look more sleek. You're like, why? You're like, why? Do you think I'm an evil person? Do Do you think I kick puppies and steal candy from babies? I would never. Sleek in the terminal, yes. OG.
N_sweep says I prefer to look sleek in the terminal LUL.
See, you might be a Python user, but you still have ethics and morality. And yeah.
N_sweep says ha 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 ha.
Aw. Okay, 4i in range 3. Oh, I see what happened. So when you when you plugged a list into the range, it turned it into an integer instead of just putting in an integer. Or no, you would decide it creates a list of 3 items, and range, if you say 3, it's creating like something, probably like an empty list of 3 items. So
N_sweep says yeah, I did range list.
Yeah. I see, because the in has to have a list. That's why you're forced to use range with this, isn't it? Because you need a list. You need something that can iterate through something. 4i in range. Round list. And then equals
N_sweep says you're right, but to be more specific, /in requires an iterable, which lists are.
oh yeah, iterable, something that can go through. Oh, all is iterables, but not all iterables are lists. Oh, okay. So you could put in like a set, I guess, or a set. I know the other one. Set or a tuple. Now, wait, I'll remind you what the difference between all 3 is, because I've definitely remembered what you taught me, and you won't have to repeat yourself again. So, a list is like a array, but it's mutable, and a set. Oh, wait, I might be missing one. Oh yeah, and a dix too. Right. So a list is like an array, but mutable, and a dictionary has a key and a definition. There's a key. They're key definition pairs, and they are. They're mutable. Maybe, or I don't know actually, but they're key. But they're definitely key. Oh, nice. Okay, and then sets. You can't have duplicates.
N_sweep says you've got it so far.
You can't have duplicates, but I also think they're immutable. Tuples are immutable, and they're just like lists, except immutable, and that's yeah. Nice, yay!
N_sweep says nailed it.
Thank you. It's because your teaching is like 1,000 times better than the Python documentation. You know what? It's really good, I think.
N_sweep says all are mutable except for tuples.
Okay.
Absolutely right.
It returns a generator. Those things are weird. Generator. Exhaust iterable. Not a list. Oh. If you wanted to print it out, you'd have to do list range. Oh, like you can't print out a generator? Like you would have to put it into a list? Whatever the heck a generator is? But what if the generator breaks? Does it have a breaker to fix it? See that in the future.
N_sweep says right.
You
if
get
you
an
print
unhelpful
the generator,
output.
you
Wow.
get an unhelpful output.
Yeah, I feel like when I get into those, like it's gonna be weird. Like this Exorcism came with like a basic introduction to like Python where they showed you some of the features in the language, and I think they mentioned generators and gave like a quick example, and it was very, very weird. Like it was just like when I first learned about recursion, and I was like, what? It was that kind of moment. It might have not been generators, though, but I think it might have. I think it might have been. Oh, intervals. I don't know what it was in that they did, but it was weird.
N_sweep says conceptually they are just iterables,
Maybe?
but creating them can be complex.
Let's see. I could always just like take a look at what that video was. Because I like. The thing is, yeah. I didn't.
N_sweep says
I kind of
decorators are
understood, but
very
not
new.
really. Oh, decorate. Maybe. I feel like I just want to skip in the video and show the code, and then if you're just like, oh yeah, that's a decorator, I'll be like, oh, then that's definitely what it was. It was just very strange. Like I thought when I saw it, I was like, this has to be a very Python specific thing, like concept.
N_sweep says a decorator looks like at I_m_a_ decorator.
I was like, oh. Let's see. This was it's called
Welcome
a brief. It's called a brief introduction to Python. It's 30 minutes long. I think they should change the name to just an introduction to Python. Would have been fine. But it was just so weird. What did they do? Because they kept refactoring. So at first they solved it in a really simple way, but then they refactored their code like 50 times to show every feature of Python and like how it can just do stuff. And then it was like, that's where things got just so weird. I don't know what it was, but it was so weird. But just looking at this, it doesn't look weird so far.
I can almost guarantee that there is a free code camp video on Yi that is labeled as brief and is 4 hours long. LUL.
Beautiful. For people who work with numbers, you think they would
says NYT, what am I typing?
Oh my god. You think they would know what brief means since, you work with numbers all day. I'm just saying. The irony. Huh. I think maybe I was just getting.
Sweep says TBF,
oh,
I've been
you know what? This
Python
isn't.
for 10
Maybe
years.
this isn't so bad. I think I was just getting confused
context,
because of all the
30
drops
minutes
that were
is
everywhere.
pretty brief. LUL.
Oh, in that context. Well, yeah, in that context, but for someone who just comes on here to like, this is their first introduction to Python. They didn't take that into consideration. That is not brief. Far from brief. For I in range 3, roundless equals. But then again, I do need to. I guess I do have to put the first number in because I can't put the first one in a loop. I think.
Wait,
yes, I can.
Intro videos like that are hard, I think.
I bet I can if I do this instead, like roundless equals number. Wait, no.
N_sweep says despite not being scalable.
Would this actually? I wonder if this would work if I do this to start it, because I'm gonna iterate it. And then, does Python support ++? Wait, no, wait. That's. I mean that's a thing, right? I think in like other languages. One, two.
N_sweep says range 3 will return 0, 1, 2.
Ah, introverts teaching one-on-one so much. Hmm. Despite not being scalable. Yeah. You see, you remove the scalability, but then in return, you get an error occurred. In return, you get quality. So, yeah, that's the trade-off. But a worthy one, and I'm sure one that like your students benefit greatly from. Well, I mean, I'm benefiting. I'm not a student per se, but I'm benefiting greatly. Line 15 for eye and
N
range.
underscore sweep says, yeah, I can make more impact with an individual than if they took a recorded course.
Plus, there's recorded courses for like everything, everywhere. Like there's a lot of great resources. But one-on-one attention is still something that is very, you know, like it's irreplaceable.
N underscore
It
sweep
really
says
is.
you're missing a colon. Smiley face.
Oh, I forgot about those things. Thank you. I was like, what is happening? Oh, wait, I don't know. I don't need this anymore. Oh wait, I'm not returning anything. That's awkward. I have to return. Return round list. Okay, if this actually works, then I'm gonna try plus plus and see. Oh damn it! Not again. Unindent does not match. Unindent. Unindent does not match any other indentation level. What's wrong? My indentation is perfect. I am.
N underscore sweep says you're one
Oh my
space
god,
off.
it is slightly off. See, look how it's so close. It's so hard to tell. This is cursed. This is why I hate Python. This is absolutely cursed. Okay, I don't think it's off anymore. Thank you for telling me. Damn it. What is it giving me?
N underscore sweep says my eyes are so trained to see that LUL.
Oh. See, Python like modified your biology, but I don't think that's necessarily a good thing. Who knows? Maybe you're like significantly more nearsighted than you would have been if you didn't learn Python for 10 years. What I
N
is in each
underscore sweep
iteration?
says think about what I is in each iteration.
Oh, I guess you did say 0, 1, 2. Wait, yeah, I wanted to do it 3 times. Because I'm returning 3 numbers, so I want to iterate 3 times. Wait, the
N
function
underscore
returns
sweep
0.
says okay, I don't love bragging, but my eyesight is outstanding. LUL.
Oh, okay. The function returns 0. Test expected round 0, 1, 2. Wait,
N
it
underscore sweep
returned.
says print your round list.
Oh wait, I'm not putting this into. Oh my god. Wait, this is a. Oh wait, I'm supposed to use like a.
N
Okay, I think I
underscore
know.
sweep says ONVM they give you the return.
I'm like, this is a. I'm like changing the type instead of it's like. Wait, did I even return? I didn't even return a list. Like I made a list, and then I think I put in like a 0 into it. Over like 3 times I put a 0 into it. Like this is why type safety. I need to put a list in here. I made. Looking for a dot append, yes, and that's not what I'm using.
Correctly at the very beginning. You're
Right.
looking for dot append.
Round list dot append.
N underscore sweep says no assignment needed here.
Oh. Oh, really? Wait, you mean like when I assigned round list? Oh wait, it didn't work again. Damn it. What am I returning? None type object has no attribute append. Okay, I think I just used append wrong. Is it really dot append? Guess so. Assignment. You reassign round lists to the output of a pen.
N_sweep says you are reassigning round underscore list to the output of append.
You're right. I just need to do it 3 times, but not reassign it into. Oh yeah, that's a good point.
N_sweep says then on the second iteration you get an error.
Okay. And second iteration. Oh wait, -1 plus 1 doesn't make any sense. Because then I'm just reversing. Oh god, okay. So then... But then, okay, so then I think there's no way. I do have to put number in here. And then just change it to 2. Because I don't see a way I can have 3.
N_sweep says remember, I is 0 the first iteration.
For the first number. Wait a second. You mean it's not for the first iteration? It's gonna skip it? It's gonna skip the first iteration for me?
N_sweep
Really?
says so the first iteration of the loop will be number 0.
I mean, that's what I wanted to do, but doesn't that seem kind of cursed to you? Wait, really? What? Wait, why did it just condense into... What the heck?
N_sweep says yes, range, 3, returns 0, 1, 2.
Yeah, but I'm just using it to count how many times I want the number bumped up. Right? Okay. Well, if you say it works with 3, then... Because 1 should be... The first number should be too high. Wait, the function returns 0, 1, 1, 1. That's 4 times.
N_sweep says AHH that
Oh, because I did this. Yeah. So I was expecting 1 to be too high. Like... Alright, what's happening here? Function return 2, 2, 2. Wait a second. It's not... What do you think about this? Number plus 1. Oh! Okay. Maybe I actually need to do... I don't know if this is going to solve it or
N_sweep
not.
says just change 1 to I.
Unnecessary? To I? Really? 0, 1? What? I'm so confused. How does this work? I know. I think this is what you were hinting at doing, but like... How?
N_sweep says number 0 is number.
You're right. Number 1 is the next round. Oh, and number 2 is the... Oh. You're right. That's what you meant. Like, the first one doesn't matter.
N_sweep says number 2 is the round after.
I see. And then it was always, when I was doing it before, it stayed like at 2, 2, 2. Because number...
N_sweep says your internal parentheses are unnecessary too.
Number never changed. Oh. Okay. You're right, that is unnecessary. That's a good point. Aha. Thank you. Oh, yeah, and then it just never took them away.
N_sweep says you had a reason for them earlier, Laughing face.
I see. Keeping all rounds in the same place. Okay. Elise played a few rounds at the first table, then took a break and played some more rounds at a second table, but ended up with a different list for each table. She wants to put the two lists together so she can track all the poker rounds in the same place. Implement a function, concatenate rounds, rounds 1, rounds 2. That takes two lists and returns a single list consisting of all the rounds in the first list, followed by all the rounds in the second list. Okay, 7, 20, 29, 35, 36.
N_sweep says I told someone yesterday that learning Python is my favorite genre of Twitch stream.
It's your favorite genre Twitch stream. Oh my gosh. Do you stream, by the way, N_sweep? But yeah, work is important. Very important. As long as you watch my streams every now and then, I feel like you should switch your favorite stream to update. Oh no!
N_sweep
cool.
says I did /will again.
Okay,
OBS
I'll follow
broke
you. Well,
when
not
I
it's
updated
not
my
cool your
OS
OBS
recently.
broke, but that's cool that you stream. Eventually. Yeah, I bet you just need to update your OBS and it will be okay. Maybe. but yeah, as long as you occasionally watch my stream, I think you should. Well, not that easy. Oh. I think you should change your favorite genre Twitch stream
N_sweep
to off
says
by one error.
unfortunately not that easy. Sad face.
Not that easy. Oh. Why? Do you know why it broke then? In that case. Oh, I should just say restart your computer. It'll fix everything. That's it. Just restart. You know. And then everything magically is always better. If your code doesn't work, restart your computer. Use a weird version of Linux.
N_sweep says not exactly, but I have an idea. I use a weird version of Linux.
You know what? I know what it is. I found the bug. The bug is you use Linux. Fully installed OS. Oh no.
N_sweep says of the OS, not OBS.
Okay, yeah. You know what? Touche.
N_sweep says LMAO don't get me started on Windows.
Let's call it even. Because the amount of problems I've had on Windows is... Yeah, that's true. Fair. Even the stream, like, I lost my mouse cursor, so I had to navigate with just the keyboard to, like, go to the device manager and, like, troubleshoot that, and then the mouse disappeared again, and then I had to fix that again, and then my alt tab wasn't working, so I just had to like mash a bunch of keys until the alt tab came back.
N_sweep says I run into stuff like this occasionally, but
Linux
my life has been significantly better since moving to Linux full time.
I don't even know what a mouse is at this point. But that's really cool. Linux is kind of cool. I was reading about Linux earlier before you came. The first thing I was doing was reading. Have you seen this site before? You might think it's cool. I think it's cool. It's called CPU.land.
N_sweep says another great thing about Linux is that keyboard-only navigation is very feasible.
Oh, cool. But basically, it talks about mainly Linux. Like if you see, like here. Like, I kind of learned how Linux executes programs. Like, this is code from the Linux kernel. But it's using it to like explain how computers work, how computers decide they want to like launch things, and how do they like how do
N underscore
programs.
sweep says, okay, yeah, I need to read this
It's
for
really
sure.
cool. Like I read it, and I'm like not even like super. You know what my level is. It's not very high, so a lot of this I can't understand well, but I understand some of the concepts I was talking about. But I think you would actually understand the actual like what's happening, especially with the Linux
N
commands and
underscore
stuff.
sweep says, very nice, thank you for the
Oh
rec.
no, my pleasure. You share great things with me, so it's the least I can do. If I find anything good, I'll share it with you. Anything I get. But yeah, don't shirk your work. But yeah, it's pretty cool.
N underscore
Oh
sweep
yeah,
says, thanks.
I did see.
And if you need any help, feel free to reach out on Discord.
Aww. Thank you, Nsweep. But yeah, you know now, as much as I complain about Python being cursed, I can't give up on Python now. Even if it never is my main language, I'll always keep, working on it, at least a little. Because since I met you, so because I have to, I have to pay my dues. I have to make you proud. And also my friend proud, who's basically a Python
N
main
underscore
too.
sweep says, that's what I want to hear, LUL.
Mm-hmm. Yeah. Mojo is coming. Oh, that's for Python,
N
right?
underscore sweep says, Mojo is coming. You'll get your performance out of Python eventually.
I will like that very much. So what really is Mojo though? Like it's not just a library then. Is it like an implementation of Python or
N underscore sweep says it's a
oh,
new
it's just
language
written
that's
like
written like
Python.
Python.
Okay, so it's like a whole separate language. And who knows what the documentation is going to be like, especially for I mean Python's a very popular language, but the documentation's so bad. You know? That makes me sad.
N underscore sweep says when it's completed it will be a
Oh,
superset
super
of
sad.
Python.
Oh, so anything I learned from Python will cross over into Mojo. So, okay. But in that case, it's fine then.
N underscore sweep says yes.
That's really cool. I mean, they have a date on that, or is it just like up in the air? I didn't know TypeScript is a
N
superset of
underscore sweep says
JavaScript.
similar to how TypeScript is a superset of JavaScript.
Wow. I don't know why. I always assumed TypeScript was like HTML or something, or some like I thought it was some like formatting language.
N
Oh,
underscore
it's
sweep
not a
says you
version
can use the
1.0
language
yet.
today,
I see.
but it's not at version 1.0 yet.
Let's see. If I ever happen to learn anything from other languages or something that could be of value to you, you're welcome to always contact me on Discord too. I know I suck right now, but if I ever don't suck, you could call on me. Aw.
N underscore sweep says thanks. You'll catch up in no time.
I already surpassed you in the amount of off by one errors I've made, so I'm, I'm officially more, of a programmer in that sense.
N underscore sweep says ha 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 ha.
Aw. I don't really know C#. It's just I've just worked in it a little. It's C# is only mildly better than my Python.
N
So
underscore sweep says I'm actually not sure that's true about the off by one
okay.
errors LOL.
Oh, Lua. Oh, there was
N
a
underscore
time.
sweep says,
Oh
especially
my
since I
gosh, that's
started
cool.
programming in Lua.
One base indexing. That doesn't seem like such a bad thing, to be honest. The zero base indexing is still kind of annoying, to be honest. I think it's still kind of annoying. But Lua, I remember a while ago, like Lua there was like an editor or something that was available on iPhone. Like you could actually like code in it, and so it was something that I was interested in. That you could do it like on mobile.
N underscore sweep says it's not, but when you're so used to zero you make lots of
Oh,
errors
but when
lol.
okay, whenever you throw, okay, that's fair. There's one language that I think has a really weird syntax. What is this programming? NeoVim.
N underscore sweep says
I've
Lua
heard
is
of Vim,
used
but I
for
don't know what that
programming
is.
NeoVim plugins.
Oh, only reason you learned it. I see. Wait a second. What is it? I think people say like Lua is like Python with better performance, in the sense of like a scripting language,
N
or a
underscore
wrapper
sweep
language
says
or
it's also
something.
used in a lot of game plugins. I know Minecraft and Factorio for sure.
Oh, oh, cool. I also heard Factorio is like the the guilty pleasure of programmers. Like the game is just really like it's like perfect for that kind of, I don't know, paradigm, I guess. It's
N
just the best
underscore
game in
sweep says
existence. Okay.
Factorio is the best game in existence.
See, then you're part of the group, the stereotype that Victoria is. Because I watched, there was like a video essay about like why Factorio is the best game ever for computer science or something, from like a programmer who was just like, Factorio is the best game ever made. And you'll learn so much about how.
N underscore sweep says it's just
Yeah.
programming but as a game lol.
Except fun, I guess. It takes all those concepts, but it makes it like fills them with sugar. It makes them really fun. Fun. Yeah. I should. I thought about grabbing
N
Factorio during the
underscore
Steam
sweep says
sale.
grab the free demo sometime.
Oh, cool. 10 hours. But then. But it didn't like drop very much. It's like a premium game. It doesn't seem to drop. Even on the major Steam sales, it drops a very small amount.
N underscore sweep says Factorio does not go on
Oh!
sale.
Okay, then that's why. It just didn't drop. If games don't drop a lot, or they just don't drop at all, then they should drop it. At least on like, I don't know, Pi Day or something. Like maybe just drop it a little. It does not go in sale ever. Okay. Okay, so you
N
played a
underscore
good
sweep
amount of
says it's
Factorio, I
only
guess.
$30. I'm almost at 0.01 per hour lul.
So what are you trying to say? You just finished this tutorial? That's good. Does Factorio have multiplayer? Oh,
N
hey
underscore sweep says
Chips.
ha 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 ha.
I'm just chatting. Well, and I was doing some Python. Oh, if I had
N
Factorio,
underscore sweep says yes it does have
okay.
multiplayer.
If I had Factorio, would you play it with me? Maybe in the future. Think about it. If I have money, though.
N
As many
underscore
as your
sweep
PC
says
can
as many
handle.
players as your
Oh, heck
PC can
yeah.
handle.
Oh, okay, cool. Okay, so in that case, if you'll play with anyone, it seems like you might not hate that game. And that's good. Very good. I'm guessing it's I'm guessing it's cooperative multiplayer. I don't know why. I got the
N
feeling
underscore sweep says
that
I
it's
might not.
cooperative when you said that. Yeah, you might not. The day I got Factorio is the day you just happen to uninstall it. Oh, and PvP modes?
N
Wow.
underscore sweep says yes, there are PvP modes but it's primarily
PvE.
intended to be PvE.
Okay, I really like that then. Just the fact that they have multiple ways to play multiplayer. Like, that's awesome. Oh, kind of,
N
yeah,
underscore
I
sweep
see.
says the PvP modes were kind of squeezed into the game.
Oh, so they feel a little unbalanced. Oh, does they tell that they made a PvE game and thought? Oh,
N
it just
underscore
okay.
sweep says
It
not
feels a little
so much
forced.
unbalanced, just you can tell that they made a PvE game and then thought how can we add a little PvP.
Hmm. That's where the fun in like game design comes in. Like the idea, like trying to make something that when someone actually plays it, they don't feel like you forced it. Like it feels natural. Like it was meant to
N
be.
underscore sweep says I've never played a PvP mode to say that it's
Oh,
actually
okay.
bad or anything.
I see. I guess since it supports as many players as your PC can handle, it's like player hosted servers. Cool.
N underscore sweep says yes.
Cool, cool. I wonder if I can play multiplayer with just the demo. Probably not.
N underscore sweep says okay
Oh
I
yeah,
must be going LUL.
you do. You really do though. Because the only way you get to keep your Python skills is you got to keep your job.
N underscore sweep says nah the demo is also the
It's
tutorial.
just a tutorial, but it's just like a lot of content. I see. Like is it? Oh, so it's like a 10-hour tutorial. Lovely. But you know, I like games with like mechanics like that. To be honest, so it doesn't actually bother me. I like content. I want to get, you know, maximum replay value out of a game. But yeah, good luck. You work hard. You love the game.
N
Okay.
underscore sweep says you like programming, you'll love the game.
Anything you've ever played, I see. And don't forget, you said it was the best game ever. Goodbye. Good
N
luck.
underscore sweep says thank you goodbye.
Like I said, work hard, make it a good day. Be productive. Okay.
N underscore sweep says or, lurk I mean, see you.
Oh, or lurk. Yeah. Heck yeah. Wait, why does everyone do that? Why does everyone do exclamation lurk? Like, what does that even mean? Is that actually like a command? Like, that's the second time I've seen that. Oh,
N underscore sweep says people often have bots that respond to it.
like bots connected to their account, not the streamer, right? That's cool though. Oh, it's salt bot.
N underscore
Oh,
sweep says like you could have a salt underscore bot for instance.
oh, I thought streamers were the ones who host the bots on their chats. I didn't know you could have your own bot like when you go to another stream.
N underscore sweep says that would send a message when a user wrote, lurk.
Oh, well, I hope I didn't disappoint you because of your exclamation lurk not doing anything.
N_sweep says, oh yeah, no, you're right. I swapped your queue.
Wait, I don't know what my queue is, but oh, just your habit when you.
N_sweep
Okay, I'm
says, not
sorry.
at all. It's just habit, the additive.
Okay.
Smiley face.
Oh, backwards. Oh, question. Swap. Hmm. Let's see. Well, good luck. Again, work hard. Don't procrastinate and play Factorio. Okay. You too. Okay, yeah. I'll see you.
N_sweep says, okay, have a great day. Always a pleasure and gone for real now, LUL.
Oh, lol. Okay. So this one's broken. I'm gonna do this one. Purchase the watercolor paint palette for $149, a pack of paintbrushes for $7.58, and watercolor paper for $7.99. Item get a calculator, hooray. Wow.
and C to take one or more arguments. You give the arguments a name, N, or whatever you want to call it. A 10-minute break. We'll see you in 10. Cookies are now served outside. All right, so we are back, and I realize this has been a lot so far, right? So there's a lot of new syntax, there's a lot of translation of Scratch over to C, but among the goals of having spent last week in C, in Scratch and
What are the problems? Hmm. What is Fedora? Linux. Why do they not have instructions for Windows? This probably won't work on.
having spent problems at 0 translation of Scratch over to C, but among the goals of having spent last week in Scratch and having spent problems at 0 in Scratch is that like none of today's ideas are really all that new. It's just a lot of syntax that will get more comfortable and more in your muscle memory as time passes. Up until now, though, we've focused largely on these side effects, like things happening on the screen, and that was akin to like the speech bubble appearing in the world of Scratch. But let's focus for just a bit before we then explore things we can't do very well in code, return values instead in C. We've seen them already, like getString returns a value, getInt returns a value, a string and an int respectively. But what if we want to make our own functions that don't just meow and return or things we mean? And that was akin to like the speech bubble appearing in the world of Scratch. But let's focus for just a bit before we then explore things we can't do very well in code, return values instead in C. We've seen them already, like getString returns a value, getInt returns a value, a string and an int respectively. But what if we want to make our own functions that don't just getString returns a value, getInt returns a value, a string and an int respectively? But what if we want to make our own functions that don't just meow and visually have the side effect of meowing on the screen, but actually hand us back some value? Well, I bet we can do this in C as well. Well, let me propose that on the screen, but actually hand us back some value. Well, I bet we can do this in C as well. Well, let me propose that to go that route, let me go back to VS Code here, and let's make our very simple calculator that just like adds some numbers together. But the same calculator we'll soon see is going to get us into trouble if you don't understand what the computer is doing underneath the hood. Let me go ahead and run code of, say, calculator.c. And in here, let me go ahead and give myself access to the CS50 library with cs50.h, the standard IO library with standard IO.h, int main void, which again we'll just take for granted today that we have to include atop any of these programs, and let's just add two numbers together. Super simple calculator. So give me a variable called x, assign it the return value of getInt, and I'll ask the user to give us x. Give me another variable called y, assign it the return value of getInt again, but this time ask the user for y. And then lastly, let's just go ahead and print out the value of x plus y, but I don't think I can get away with something like this, x plus y. Y semicolon, because if I do y, but I don't think I can get away with something like this, x plus y semicolon, because if I do this based on what we've seen before, I can get away with something like this, x plus y semicolon, because if I do this based on what we've seen before, what's actually going to get printed out? Right, literally like x plus y. So I think this is where I need the f in printf for formatting. What I think I really want to do is print out the value of some placeholder, because what do I want to substitute for %i? Maybe as a second argument to printf intuitively? Maybe just x plus y. So indeed, I can get away with this, because it turns out in C, there's a bunch of arithmetic operators, all of the ones that you might expect, including addition, subtraction, multiplication, division, and even this one, the called modulo operator, which generally gives us the ability to calculate a remainder when you divide one number by another. But I'll keep it simple with addition. And indeed, with printf, if I want to print out the value of x plus y, I can do that, but I have to tell printf what kind of value to expect, an integer, thus the %i instead of %s for string. And I think this should do the job. What kind of value with printf, if I want to print out the value of x plus y, I can do that, but I have to tell printf what kind of value to expect, an integer, thus the %i instead of %s for string, and I think this should do the job. So let me go back to my terminal, make calculator, enter. All is well so far, /calculator, and let's keep it simple. 1 for x, 2 for y, and indeed, I get 3 as the output. It's not very dynamic. It can't do a subtraction or multiplication or much more, but it does at least do those kinds of calculations. But let me propose now that we maybe make a reusable addition function, right? Because addition is something I'm going to do a lot, and maybe it should be abstracted away with a function, just like meowing was abstracted away a moment ago. So let me go ahead and instead of doing this, let me go ahead and give myself a function called add, but instead of last time, where I had a meow function, I'm obviously going to call this add instead. And instead of last time taking in no arguments, I think I want add to work a little differently. I don't want add necessarily to take an argument yet, but I do want add to return some type of value. And just intuitively, like what type of value should an addition function return? An integer, so an int. So I'm going to change void, which means the absence of a return value, nothing's coming back, to literally int. But I'm not going to change the thing inside parentheses yet. I'm going to go ahead and do add necessarily of, but instead of last time, where I had a meow function, I'm obviously going to be abstracted away with a function, just like meowing was abstracted away a moment ago. right? Because addition is something I'm going to do a lot, and maybe it should be abstracted away with a function, just like meow. Of last time taking in no arguments, I think I want add to work a little differently. Myself a function called add, but instead of last time, where I had a meow function, I'm obviously going to call this add instead. And instead of last time taking in no arguments, I think I want add to work a little differently. I don't want add necessarily to take an argument yet, but I do want add to return some type of value. And just intuitively, like what type of value should an addition function return? An integer, so an int. So I'm going to change void, which means the absence of a return value, nothing's coming back, to literally int. But I'm not going to change the thing inside parentheses yet. I'm going to go ahead and copy my prototype up here, and I'm going to make this change, the thing inside parentheses yet. I'm going to go ahead and copy my prototype up here, and I'm going to make this change, return x plus y. And then here, instead of printing out x plus y, let's go ahead and do this. Let me give myself a third variable just for now. Z equals the return value of this brand new add function that's going to add x plus y for me. And then let me print out the value of z. Instead of x plus y, I'm outsourcing now to this add function, so it will do the addition of x plus y. So similar in spirit to meowing, but the return values I claim are about to create an issue. So let me make calculator again, and there's definitely some meowing, but the return values I claim are do the addition of x plus y. So similar in spirit to meowing, but the return values I claim are about to create an issue. So let me make calculator again, and there's definitely some error. So here we have use of undeclared identifier x, and that's on line 17. So that's pretty far down in the file. So specifically, my compiler does not like my use of x on line 17. But wait a minute, x is clearly defined on line 8. What intuitively might explain this issue, even if you've never programmed before? Yeah? Yeah, because x and y are defined in the main function, not in the add function. So the term of art here that we're about to introduce is something called scope. So scope just refers to the context in which variables exist. The context in which variables exist. So by that I mean this. On line 8, I've declared x. On line 9, I've declared y. But the catch is, and here's where the curly braces are helpful, those variables only exist in the context of the outer curly braces that are nearest to them like this. So I can use x and y on lines 10, 11, 12, and even up to 13, but not thereafter. So I certainly can't use x down here on line 7. But this is a problem, because if add's purpose in life is to add x and y, but add can't access x plus y, well, we have an issue of scope. Like x and y are not in scope for this add function. But that's OK, because remember that every function we've seen thus far can have maybe a return value or a side effect, but it can also take 0 or 1 or 2 or more inputs known as arguments. So what if I instead do this? Let me clear my terminal window. And let me update add to not take nothing as input, but maybe 2 integers. And I'll call them arbitrarily a and b. But I have to tell the compiler what type of arguments they are. 2 integers, one after the other. And now what I can do is this. Let me change this up here too, int a, int b, just so that the prototype is exactly the same. And the only purpose of this prototype is just to avoid the previous error where the compiler didn't realize add was going to exist because it came later in the file. So here on line 11 now, if I want to add 2 values, x and y, this is now the syntax. We saw syntax in Scratch for passing in inputs to tell it how many times to meow. So this is just telling add what 2 numbers to add together. So now I have to change this to a plus b for reasons we'll soon see. And let me see if this is right. Make calculator. So far so good. Dot slash calculator. Let's do 1 and 2 for x and y respectively. And hopefully we should again see 3. Now what's going on? So here again, if I zoom in on my add function, this int here on the left on line 15 means what about add? This means that it has a return value that it's an int. So it's going to hand me back, metaphorically, a slip of paper with an answer on it that is of type integer. It's not a word like my name. It's a number instead. These mentions of int here and here are inside the parentheses, which means this function add takes 2 inputs. The first is an int. The second is an int. And just so we have something to call them, I call them a and b respectively. So what happens essentially when I call the add function now on line 11, I'm kind of passing in x. I'm passing in y. But the add function is going to think of them as a and b respectively. It could call them anything I want. I could change this to the word first and second, and then I could literally change this to first plus second. Those are perfectly acceptable as argument or variable names, but who really cares? Like a and b for such a simple function is perfectly reasonable too. Technically, if your mind is going there, I could even call them the exact same thing, but let me propose for today, certainly don't do that, because it just confuses things. If you've got x's and y's here, but they're clearly different, just don't do that. Try to come up with different variables just to keep yourself sane. But here, I have a function that takes now 2 integers, a and b respectively. It just returns the sum of them so that I can now store the return value of add in a variable called z. And then, quite simply, so that I can now store the return value of add in a variable called z, and then, quite simply, print it out. But there's one other thing I can do here.
Okay, I'm gonna be right back. God, what is it this time? Oh, I got this one wrong. Oh my god, bad. What if I did this? What are the odds I would not get this one? 1, 2, 3, 4, 5. I feel like here, I'm gonna use the calculator just because I got cheated earlier. So I think it's fair. Oh god, this might be the one where I get cheated. Praying I don't. Damn it, it's one of these ones. One of the freaking broken ones. Which is not the. That's why these aren't fair. I mean, I could finish this by cheating. This one is 3.135. It's crazy. this one's going to be 3.13. This one's also 3.1. Insanity. Wow, this one actually has the right answer. Shocking. Okay, how many are there? 26 minus. Oh, I have this one recorded. 6.597. Well, what was this one? We have to use a freaking lookup table. verify. What is this one? Oh my god.
Now if we think about design, even if you've never programmed before, do I really need the variable z? Because I'm defining it on line 11 and then I'm quickly using it on line 12 and like that's it. Like sometimes you don't need variables and they might make your code more readable, but strictly speaking, and this is just kind of like substitution in math, if z is the same thing as add x comma y, well let me go ahead and just delete line 11 altogether. Let me get rid of mention of z. You can actually get away with doing this. And much like the join block in Scratch where I kind of overlaid it on the say block, like kind of stacking them, you can stack functions in C or nest them really kind of mathematically. Honestly, it makes it a little harder to read because your mind has to kind of dive in conceptually deeper and deeper into this second argument, but it's perfectly acceptable too. And just to connect the dots to maybe something from high school, this is kind of analogous to a function in math class being like f of x, where f is some function name, x is some arbitrary input to that function. And when you start to put functions inside of functions so that the output of one becomes the input to the next, it's like using this syntax, f of g of x and so forth. If you put functions inside of functions so that the output of one becomes the input to the next, it's like using this syntax, f of g of x and so forth. If you've never seen that before, don't worry, but if you have, it's a way to connect some. Some of these dots. Any questions though on just this and so forth? If you've never seen that before, don't worry, but if you have, it's a way to connect some of these dots. Any questions though on just this idea of now having a function that doesn't just have a side effect, but instead has a return value?
ChatGPT. This function.
Yeah, and back. In our definition of main, what did I do what? Oh, a really good question that I was trying to sweep under the rug for today, but in every one of our
Okay, what is the example?
in our definition of main, what did I do? What? Oh, a really good question that I was trying to sweep under the rug for today, but in every one of our programs thus far, I have indeed said int main void. Technically speaking, whenever you write a program and it finishes running, it actually returns a value somewhat secretly. It returns the number 0 by convention, which means all is well, and it can return any other integer if something goes wrong. In fact, on your Mac, PC, or even phone, if you've ever gotten like a weird message on the screen, like something went wrong and it's like a weird numeric code, like error -129 or something arbitrary like that, that tends to mean that some program running on your Mac, PC, or phone had something go wrong with the main function, and that is the number that was returned. But that's more than we want to talk about today, but we'll come back to this. But main always returns a number. By default, it is 0. More on that soon. Talk about today, but we'll come back to this. But main always returns a number. By default, it is 0. More on that soon. All right, so with that said, let's actually tease apart what it is we've been using underneath the hood here a little bit by returning to VS Code's interface itself. It turns out that all this time, even though I keep alluding to Mac OS and Windows, which like 99% of us are probably running on our laptops or desktops, there's actually other very popular operating systems in the world, among which is Linux. So Linux is a very popular operating system, the thing that turns on, the thing that boots up when you first turn on a computer. And it's very commonly used for servers. Nowadays, all of CS50's own servers run some version of Linux. Those students more comfortable sometimes run Linux on their own Macs or PCs even. So Linux is a very popular operating system. Those students used for servers. Nowadays, all of CS50's own servers run some boots up in the world, among which is Linux. So Linux is a very popular operating system, the thing that turns on, the thing that boots up when you first turn on a computer, and it's very commonly used for servers. Nowadays, all of CS50's own servers run some version of Linux. Those students more comfortable sometimes run Linux on their own Macs or PCs even. So Linux is a very popular operating system, and it's particularly characterized by its textual interface, its command line interface, even though it also comes with graphical ones as well. So again, this term we started today with a graphical user interface is a thing with menus and buttons. It's literally what you and I use every day on our devices, otherwise known as a GUI. But today onward, you'll get more comfortable with and more practice with this terminal window down here, which represents a command line interface, or CLI. And just so you have a mental model of what's going on in the cloud here, when you access cs50.dev, you are accessing this version of VS Code in the cloud, a piece of software just running in a browser. But that piece of software is automatically connected to your very own personal server in the cloud, so to speak. Technically speaking, it's a Docker container, but it means that you have your very own personal server software just running in a browser. But that piece of software is automatically connected to your very own personal server in the cloud, so to speak. Technically speaking, it's a your very own But that piece of software is VS Code in the cloud, a piece of software just running in a browser. But that piece of software is automatically connected to your very own personal server in the cloud, so to speak. Technically speaking, it's a Docker container, but it means that you have you're essentially your own mini server in the cloud, Docker container. But it means that you're essentially your own mini server in the cloud that only you have access to. And that server or container is running an operating system called Linux. And in fact, every time I've been running a command down here, which is running an you have access to. And that server in the cloud that only you have access to. And that server or container is running an operating system called Linux. And in fact, every time I've been running a command down here, whether it's code or Linux, and that server or container is running an operating system called Linux. And in fact, every time I've been running a command down here, whether it's code or make or /hello or anything else, I've been running commands from here in Sanders Theater on a server somewhere in the cloud, my own Linux container or server, and you'll have the same yourself. This is the thing that we have pre-configured for you by installing the compiler and so many other pieces of software you'll soon see in the class. But underneath the hood then of Linux is a soon-to-be familiar environment that allows you to run different types of commands. And those commands include things like this. And this is something you'll develop muscle memory for over time, but I wanted to give you a sense of some of the most popular textual commands, because we're essentially about to take away muscle memory you have from a GUI world and have you type out words that represent double-clicking on things, dragging on other things, and other such commands that you and I take for granted. It'll be a little painful at first, in the first days or weeks, but it will make you far more productive long-term, so that even after CS50, if you start using your programming skills in some other domain, class, or real-world job, you'll just be a lot faster at the keyboard and able to do more work more quickly. So with that said, let me go back to VS Code over here. I'm going to go ahead and open up my File Explorer over here, and you'll see at left all of the files that I've created thus far in class and all of the programs that I've compiled thus far in class. I also have this source1 directory, which you can download from the course's website, which has all of today's code pre-written in advance, so you don't have to type everything that I literally type. But all of these files are things that I've created, and you'll see that in white are the C files, and grayed out are actually the binary files, the machine code that I created that I was running. So you can click on any of these files in VS Code to open them. For instance, here is hello.c, and voila, it opens in the text editor. But if I try to open hello, that's not going to work, because that's zeros and ones, and frankly, the computer could show me all those zeros and ones, but it's just not going to be useful. And honestly, it's too easy to make one mistake and break the whole thing. So instead, VS Code says that it can't display the text because it's binary or maybe unsupported more generally. So know that you want to only click on the .c files when writing C code. But let me go ahead and do something else. Suppose that I decide that, wait a minute, we're nearing the end of class, and we're not done yet, but what if I want to change hello.c to goodbye.c, or if I want to change meow.c to woof.c and turn it into a dog? Well, let's actually do that. I could go over here and right-click or control-click on the file, just like on a Mac or PC. I can find the rename option, and I can do it all via the GUI. But you should get more comfortable and find the rename option, and I can click or control-click on the file, just like on a Mac or PC. I can find the rename option, and I can click, turn it into a dog. Well, let's actually do that. I could go over here and right-click or control-click on the file, just like on a Mac or PC. I can find the rename option, and I can do it all via the GUI. But you should get more comfortable using commands like these here. And among the commands on this list are mv for move, aka rename. So for instance, if I want to change meow.c to be woof.c instead, I literally type mv space, the original file name, space, and the new file name. So this is very similar to what I've already been doing with the code program or the make program. I not only type the name of the command, but also the thing that I want to code or the thing that I want to make. In this case, I type the thing that I want to move from old to new. Now, if I hit enter in a moment, watch on the left-hand side, meow.c in the GUI should automatically change, even though I'm doing this all via the command line keyboard interface. And now it becomes woof.c. All right, I mean, it's not all that exciting, but this is just to say that they are one and the same. One is a GUI, one is a CLI, but it's the same exact thing. Moreover, let me go ahead and close now the GUI at left, the so-called Explorer. And in my terminal window alone, now I'm kind of out of my element. Like, wait a minute, what was the file I created earlier? Well, there's other commands as well. On this list is, coincidentally, ls, which lists the file in your current folder. And as you might have gleaned here, mv for move, ls for list, like CS people like to be succinct, terse, and type the minimal number of keystrokes. That's why these are all abbreviated commands instead of full words. But if I go back to my terminal window and type ls, voila, there is exactly the same contents of my server, abbreviated commands and succinct, terse, and mv for move, ls for list in your current folder. ls, which lists the commands as lists the file in your current folder. ls. Clear? Well, there's other commands as well. On this list is current people commands instead of full words. But if I go back to my terminal window and type ls, voila, there is exactly the same contents of my server, but displayed textually. And there's some heuristics here. In green with an asterisk is all of the programs that I made with make that are executable. So the asterisk just means this is executable with /. Meanwhile, the source one directory, which only I have because I downloaded it in advance, has a / to indicate that it's a folder instead of a file. But all of these white files ending in .c we created together here today. Now, what if I really am embarrassed by my very first program, hello.c? Well, I can very destructively go and use the rm command for remove. And rm hello.c is going to prompt me, a little cryptically, remove regular file hello.c. And amazingly, this rm program has code just like we wrote earlier for agree.c, where I can type y to delete it. I can type n not to delete it, but let's delete it. Let's go ahead and hit y, enter. Nothing seems to happen, but in general, that's a good thing. But if I type ls again, notice what is now missing. And in fact, the list is a little shorter, so it's one line instead of two. Hello.c is now gone. Now, if you do that, there are not easy ways to get the file back, so don't do that unless you really want to. Instead of 2, hello.c is now gone. Now, if you do that, there are not easy ways to get the file back, so don't do that unless you really want to, but there are backups maintained of these files as well. Well, what else is there too? Well, there's but there are not easy ways to get the file. C is now gone. Now, if you do that, there are not easy ways to get the file back, so don't do that unless you really want to, but there are backups maintained of these files as well. Well, what else is there too? Well, there's all of these other commands, and you'll experience them over time, like cp is copy, mkdir is make directory, rmdir is remove directory. And for instance, let me just show you one folder. If I type ls, there's that source one folder that I claimed I downloaded in advance. If you want to see what's there, you can type cd for change directory, source one, enter, and voila, notice that your prompt has now changed. And let me clear the screen. Just as a visual reminder of prompt has now changed. And let me clear the screen. Just as a visual reminder of where you are, you can see before the $sign now the name of the folder that you're inside of. So in Mac or Windows, you'd see obviously a graphical folder. Here, you just see a little textual reminder of where you now are. And if I type ls, you'll see that I wrote a crazy number of files before class, and each of these represents different versions of the files that we've been coding here in real time that I usually have printouts of just to go through things in series. Versions of the files that we've been crazy number of files before class, and each of these represents different versions of the file. Crazy a little textual reminder of where you now are. And if I type ls, you'll see that I wrote a crazy number of files before class, and each of these represents different versions of the files that we've been coding here in real time that I usually have printouts of just to go through things in series, so you have copies online as well. So in short, all of these commands, if you've never used them before, they will soon become like muscle memory, and they do the most basic of operations, but there will be other commands that we'll see over time that do even much more than that. But let's go ahead now and solve some actual problems. And it's no memory, and they do the most basic of operations, but there will be other commands that we'll see over time that do even much more than that. But let's go ahead now and solve some actual problems. And it's no coincidence that we keep showing or alluding to Super Mario Brothers in some form, an older game from the Nintendo Entertainment System that allows you ultimately to have this two-dimensional world where Mario moves up and down and side scrolls from left to right. But you'll see we can distill even some aspects of Mario into some fairly representative programming problems. And in fact, let me propose that we consider this screen from the original Super Mario Brothers. So there's these four blocks in the sky, each with a question mark. And if you click on one of the, if Mario jumps up underneath each of these question marks, he gets like a coin or something else that pops out. Let's distill this, though, into its essence and consider in C, how can we make, not a blue sky yet, not a green grassy hill and so forth, but how can we just make 4 question marks in a row? Because I dare say that we do have the building blocks via which to do this. Well, the simplest way might be to go over here and run code of mario.c. And then in mario.c, let's include some standard io.h, so we have printf. Let's do int main void as we keep doing. And inside of main, let's keep it super simple. 1, 2, 3, 4, backslash n. Doesn't get much simpler than that. This is not going to be the prettiest of games, but if I make Mario now, /Mario, I get my 4 question marks in the sky. All right, so it's not all that interesting, but this is clearly a candidate for what type of programming feature? Not just Scratch, though Scratch would make it more interesting, yeah? So some kind of loop, right? So print the thing out iteratively instead. So let me do that. Instead of just printing this out all at once, let me go ahead and remove this and do for int I gets 0, I less than 4, I plus plus. And then in here, let me go ahead and print out just 1 question mark instead. And now let's run this. So make Mario to recompile it, /Mario. And does anyone not want me to hit enter yet? Why? Oh, yeah. It's going to print out a new line every time. So notice it's 4 question marks, but they're on each on its own line. All right, well, let me fix this. It's obviously because of the \n. So let me remove that. Let me rerun make Mario, /Mario. And it's better in one way, but worse in another. So wait, but now the $sign is doing that thing where it's on the same line, which just looks stupid, if nothing else. So how can I fix that? Yeah. Yeah, so logically, we don't have that many building blocks today. It's a lot of new syntax, but it's not that many new ideas. Let's just use printf to print out literally one. That many new ideas. So logically, we don't have that many building blocks today. It's a lot of new syntax, but it's not that many new ideas. Let's just use printf to print out literally one and only one of these \n's, but outside of the loop, so it happens after all 4 of those have been printed. All right, let me do make Mario again, /Mario, and okay, now we're back in business. So sort of silly syntactical details, but if you reduce the problem to its essence, it should hopefully logically become clear over time. All right, well, how about not just something that, but vertical? Well, we've done something vertical already, and so I can imagine we could change the program to very simply print out 3 bricks instead of 4 question marks. But what if we consider a 2-dimensional world? And later on in this game, if you go underground, everything looks like this with lots of bricks. And let me propose, for the sake of discussion, that this big wall here is like a 3x3 grid of bricks. So it's not just a single brick, it's like 3x3 or 9 total. Now things get interesting. And let me go back to Mario.c. I could kind of take the easy road out and just say, all right, well, let's print out, or printf, about 1, 2, 3, \n, close quote. And then, okay, let me just copy paste. And I'm using hashes instead of the actual bricks, but aesthetically, it's pretty close. Let me now go ahead and make Mario again. /Mario, and it doesn't quite look like a square, but that's just because the hashes are a little taller than they are wide, but it is correct, but not well designed. So here too, what would be better designed than just hard coding, typing literally all of these hashes? Yeah. Interesting, 2 loops, and why 2 loops instead of 1? Okay, it's the right instinct. So 1 for vertical, 1 for horizontal. And even though these predate most of us, like old school typewriters, you might know or might recall that if you feed a piece of paper into it, you can sort of print like line, then it scrolls, line, then it scrolls, line, then it scrolls. This is kind of how the terminal window works too. You can print rows and columns, but you have to print 1 row at a time, 1 row at a time, 1 row at a time. It's not easy, but it is possible to like go backwards and sort of go up and down, but just going row by row by row is more typical. So backwards and sort of go up and down, but just going row by row by row is more typical. So how can I do this? Well, I could use at least 1 and maybe even indeed 2 loops. And this is where we're just now composing different ideas from today and even last week. So let me go ahead and say for int I gets 0, I less than 3 for a 3x3 grid, I plus plus. And now let me cheat slightly. Let me print out just 3 of these here. And that's it. So I'm kind of cheating. I'm printing out rows dynamically, but I'm still printing 3 columns all in one breath. But let's see what happens. Make Mario, /Mario, and it does work. But what if you said, no, I want 4x4, or 5x5, or 6x6? Now I have to change like the 3 to a 6, and I have to add another 3 hashes here. Like things get messy if we don't do this mathematically. So let me now do this instead. why don't I go ahead and print out every row at a time, but for each row, let me use another loop to decide, like rat-a-tat-tat from left to right, how many do I want to print. So to do this, I could do another for loop. I could call this variable something different. J is pretty common. We start at I, we go to J. If you go past K, maybe L, you're probably doing something wrong. You don't want nested, nested, nested loops, but 2 is OK. J equals 0. J is less than 3. J plus plus. And then here, I can print out a single one of these and no new line. I don't want to screw up like I did before, so I'll just do 1. Let me go ahead and do make Mario now, /Mario, but when I hit enter, this is not correct yet. What's it going to look like? A single line of 9 hashes, I think, because I never used a single \n, so that looks wrong. So on between what line number should I insert a printf of \n? Let me look a little farther back if I can. How about over here? Yeah. Between 10 and 11. So I'm going to go in here. I'm going to add printf quote unquote \n semicolon. Let me go back and recompile Mario, /Mario, and crossing fingers, voila, perfect. I printed out now a 3 by 3. Now it's correct, it's not, if we want to be really nitpicky, maybe still not the best design. Where am I perhaps repeating myself? Where, yeah. Yeah, I mean, it's not a huge deal, but now I have 2, what people would call these magic numbers. Magic in the sense that, like, where did that come from? You just randomly put it in the middle of your code, and you also put the same thing here. Now I have to make sure I don't screw up and make one change but not the other. So it turns out we can factor these out. I can actually do something like this. Int n equals 3, and then I can just change this to n, and this to n, which is marginally better because now I only have to change n in one place if I want to make this thing bigger or smaller. It's still going to work the same, so make Mario, /Mario, there's our 3 by 3. But if I want to make a 5 by 5, let me change the n to 5, rerun make Mario, /Mario, and now it's a bigger grid, 5 by 5. But this is a little fragile, and it turns out there's another trick we should introduce. It turns out that C supports what are called constants, whereby if you have a variable that you want to exist because it's useful, but you don't want to accidentally change it, or if you're working with a partner in class or a colleague at work, you don't want your partner or colleague to accidentally change that value with their own code, you can go into your code and tell C, this is actually a constant integer, a const, so to speak, and this will just prevent you or someone else from doing something stupid by accidentally changing it elsewhere. The code is still going to work the same, /Mario, but you won't be accidentally able to change it very easily to something else. And honestly, what we've now done too is set ourselves up to make this more dynamic. Let me go up here. Let me add the CS50 library so that we have access to getInt, because now we could do something fancy like ask the getInt function for the size of this brick wall, and then we can use n dynamically. So for instance, let me increase the size of my terminal, make Mario, /Mario, size 3, gives me a 3 by 3. /Mario, size 5, gives me a 5 by 5. /Mario, how about 50, gives me a crazy big one, but it's all dynamic. And now I don't have to even change the code. It just now works. As an aside, if you're wondering how I type so darn fast, sometimes it's just because I'm hitting the up arrow. It turns out that Linux will remember, if you configure it this way, all of your previous commands. So if you hit up, 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 I can go through the past couple of hours of commands that I've typed, which is useful sometimes, not for hours of commands, but the past few, just to save yourself some keystrokes. And another trick in a terminal window is to do this. If I do /MA and I get bored and I don't want to type out RIO, I can also just hit tab and it will autocomplete based on the characters that do match. So those kinds of tricks too will save you time over time. But let's do this. It's kind of broken, arguably. If I do this, how about cat? All right, well, that works. That prevents me from doing something stupid because getInt only accepts integers, but it will accept 0, which does nothing. It will accept -1, which does nothing. And that's not bad. It's not doing something weird, but it would be nice to catch that and force the user to give us a positive integer instead, so we at least see something on the screen. So let me go back into my code and let me propose that now that we have the CS50 library, why don't we do something like this? I'm going to change this. I'm going to get rid of the constant just in case the user needs to type it again. And what if I do this? While n is less than 1. So if it's 0, -1, -2, or whatever, let's go ahead and again ask the user for an int and ask them for the size again. And therefore, only once n is not less than 1 will this loop break out, and we'll proceed with the rest of the code. So now let me try this. Make Mario, /Mario, 0. Didn't like that. -1. Didn't like that. -2. Didn't like that. 3. It did like that. So using a loop now, I can sort of ensure that the human is providing me with input that I actually want. So this is correct, but I dare say 6 through 10 could be done better. Why is this poorly designed instinctively? Yeah. Well, I mean, what's the repetition, to be clear? What lines? Six and 9. Like, okay, so they're literally the same, and that's generally not a good thing. And maybe I could change this one to remind the user, like, hey, that's not a positive number. So you might want to customize the message, but just having copy-paste here for the most part is not a good thing. So it turns out, and there's just one feature of C we wanted to introduce you to today, it turns out there's one other way that will actually help us eliminate this redundancy of using getInt twice, and particularly asking literally the same question, size, twice in duplicate. So I'm actually
really shorts.
If you know your value will never be negative. You'll
Really cool.
actually going to go into my code here, and I'm going to delete the loop as we've written it thus far. And instead of using a while loop, I'm going to introduce instead something that we typically call a do while loop, which is a little bit different. Indeed, we begin with the keyword do. We call it thus in duplicate. So I'm actually going to go into my code here, same question, size, of using getInt twice, and particularly asking literally the same question, size, twice in duplicate. So I'm actually going to go into my code here, and I'm going to delete the loop as we've written it thus far. And instead of using a while loop, I'm going to introduce instead something that we typically call a do while loop, which is a little bit different. Indeed, we begin with the keyword do, and then inside of the curly braces, what I'm going to do here is that thing I might want to do once and more times thereafter. So for instance, I'm going to say I might want to do, and then inside of the curly braces, what I'm going to do here is that thing I might want to do once and more times.
Oh my god, I'm going crazy. I thought I heard TTS.
Times there. What I'm going to do here is that thing I might want to do once and more times thereafter. So for instance, I'm going to say n equals get underscore int, quote unquote size, and then at the bottom of this block of code, then I'm going to use the keyword while, as well as parentheses as always for a Boolean expression. And here I'm going to ask the question, do this while n is less than 1. But there's one fix I still need to do here, because notice on the current line 8, I actually haven't given n a type. I haven't declared n yet, but it would not be correct to declare n here. Inside of that do block. But why might that be? Why would it not be a good thing to declare n inside of these curly braces? Yeah, so recall that this is an issue of scope. Recall that the scope of a variable is generally confined to the most recently opened curly braces in which that variable is declared. And so if I declare this variable on line 8, I'm not going to be able to use it on line 10. But there is a fix, even though it might look a little strange. I'm going to go above my do block here, and before I go into this loop, I'm actually going to declare n to be an integer, but semicolon, end of thought. I'm not going to bother giving it a value because I know logically I'm going to end up giving it a value anyway. Now, on my value, declare n to be an integer, but semicolon, end of thought. I'm not going to bother giving it a value because I know logically I'm going to end up giving it a value anyway now on line 9. And so what's different about this version of the code is that the do while loop ensures that we prompt the user for input at least once, and then while that input is not what we expect, for instance, less than 1, then it's going to while that ensure line value because I know logically I'm going to end up giving it a value anyway now on line 9. And so what's different about this version of the code is that the do while loop ensures that we prompt the user for input at least once, and then while that input is not what we expect, for instance, less than 1, then it's going to execute again, again, again. And indeed, the semantics are just that. Do the following while this Boolean expression is true. So if I go ahead now and rerun make Mario, compiles OK, /Mario, and now I'll go ahead and input something that's not correct, like 0, but I'm prompted again. I'll input something like -1, and I'm prompted again. But if I go ahead and input, for instance, 10, now, because that's a positive integer, I indeed get a 10 by 10 grid of bricks. And there's one other thing we should introduce here too in C too. C supports comments. And a couple of you have asked about this if you come from other programming languages. Suppose I want to remember what it is I just did with this program. Let me go in between lines 5 and 6 here and do / prompt user for positive integer. This is what's known as a comment. And it's grayed out only in the sense that the compiler is not going to care about this. The computer is not going to care about this. This is a note to self, like a sticky note in the context of Scratch. And it starts with // which essentially tells the compiler, ignore this. This is for the human, not for the computer. But this comment, so to speak, is a the compiler ignore in the context of Scratch, and computer is not going to care about this. This is a note to self, like a sticky note in the context of Scratch, and it starts with // which essentially tells the compiler, ignore this. This is for the human, not for the computer. But this comment, so to speak, is a way of just reminding yourself, reminding your colleague, reminding your TF what it is a few lines of code are meant to do. And now this comment might be a few lines of code are meant to do. And now this comment might be print and how about n by n grid of bricks. And what's nice about comments is that theoretically you can get away with, or someone else can get away with, just reading this comment and then like not even have to look at the rest of the code. They can look at this comment and not have to look at the rest of the code because you've described for them what it's meant to do. Yeah? Sure. Correct. The hash sign in Python as a comment is not the same thing in C. In C, hash include means to include the libraries. Is not correct. The hash sign in Python as a comment is not the same thing in C. In C, hash include means to include the library's header files in that way. Other questions on these here tricks? In that way. Other hash include means to include the library's header files in that way. Other questions on these here tricks? No? All right, so as promised, what is maybe C not actually good at? Well, let me propose that we consider what's actually inside of your computer. At the end of the day, whether it's a Mac, PC, iPhone, Android phone, or some other computer device, there's something that looks like this. And this is memory, otherwise known as RAM, or random access memory, for reasons we'll get to in a few weeks. But this is where data is stored. This is where hello world is stored. This is where 1 and 2 and all of those numbers are stored. Any data in your program is stored ultimately in the computer's memory. And the most important takeaway for today is that all of us only have a finite amount of memory in our devices. You might have a high-end device which has a lot of memory, but it's still finite, which means you can only count so high with that device, you can only store so many files with that device. There are fundamental physical limitations, even though mathematically, theoretically, we should be able to count toward infinity. So what are the implications for this? Well, consider this. In the world of numbers, as per week 0, if you're only using 3 digits, and I've grayed out the 4th one just to make the point, if you're only using 3 digits, we can count from 0 to 1 in decimal, to 2, to 3, to 4, to 5, to 6, to 7. And as soon as you count to 8, you technically, per last week, need a 4th bit. But if you don't have it, the number 7 might seem to be followed by what number instead? Zero. The sort of number overflows, so to speak, right? You carry the 1, but if there's no place to put the 1, because there's no 4th light bulb, if there's no 4th transistor, if there's no 4th bit, the lower bits, the zeros, are going to be mistaken for the number you and I know as 0. So integer overflow is a thing in computers whereby if you don't have enough memory, if you count high enough, the number will wrap around back to 0, or sometimes it will wrap around to a negative number, depending on whether the code supports negative and positive numbers and 0 alike. Number, depending on whether the code supports negative and positive numbers and 0 alike. So that has some very real-world implications, integer overflow. That's sort of a fundamental limitation of how numbers are typically stored. Now, thankfully, we typically don't store things based on number of digits, but number of bits. And a bit is just a 0 or 1, and recall from last week that a common unit of measure is minimally 8-bit. Thankfully, we typically overflow. That's sort of a fundamental limitation of how numbers are typically stored. Now, thankfully, we typically don't store things based on number of digits, but number of bits. And a bit is just a 0 or 1, and recall from last week that a common unit of measure is minimally 8 bits, or a byte, but even more commonly is 32. So for instance, here are 32 bits, all zeros, and if you do out the math, this is the number you and I know in decimal as, of course, 0. But if I change all 32 zeros to 1s, this is a really big number now. If we're only using positive numbers, not negatives, what number roughly is this? 32 ones. It's roughly 4 billion in total. Roughly 4 billion in total. Why? Well, if you've got 32 bits, each can be 2 possible values, 0 or 1. That's 2 to the 32nd power, which is roughly, I'll stipulate, roughly 4 billion total. The problem is, what if you want to count to 4 billion and 1? That's a bit of a white lie. It's not precisely that. But what if you want to count just higher than that? You need a 33rd bit because all of the others are going to go to 0 at that point, and you might count from 1 to 2 to 3 to 4 billion back to 0, or worse if you're dealing with negative numbers too. So the fact that there are finitely many bits used in computers is a problem, and negative numbers do add a complexity because this is specifically the 4 billion in question, 4,294,968,295. That is as high as you can count with 32 bits if you don't bother with negatives. But if you want negative numbers, you got to have that because you got to save half of them for negative, half of them for positive, give or take. And so if you're reporting negative numbers, as you probably should for a calculator, for Microsoft Excel, Google spreadsheets, you can only count as high up as 2 billion, roughly, or negative 2 billion, roughly, instead. 2 billion, roughly, or negative 2 billion, roughly, instead. So it turns out that when you are using data types in C, you have some control over how many bits are actually used. And this list is longer than we've covered today, but we did talk about integers for a while. Those are by convention nowadays 32 bits. If that's not enough, you can upgrade your variables to longs, which tend to be 64 bits instead, which isn't just twice as big as an integer. It's actually 64 bits, which is exponentially more. It's an unpronounceable number. Integer. It's actually tend to be 6. If that's not enough, you can upgrade your variables to longs, which tend to be 64 bits instead, which isn't just twice as big as an integer. It's actually 64 bits, which is exponentially more. It's an unpronounceable number, at least for me. That's a crazy big number, but it's available to you. Moreover, we can see this if we actually are a little reckless with how we're using code. And just so you know, too, though, there are functions even in CS50's library that let you use these larger values. Get long, of course, will get you a long. And this one's a little non-obvious, but %li is the format code for printf, just so you know, for printing a long integer and not just an integer. So it's 2 characters instead of 1. Suppose, though, we actually want to use code involving some large numbers. It turns out that certain bad things can happen. So let me go ahead and do this. I'm going to go back over to VS Code here, and I'm going to modify my calculator to do something that at a glance should be perfectly reasonable. Let me go ahead and open up calculator.c as before, and where we left off, we had this add function. And you know what? I'm going to simplify it back to its very original version. I'm going to go ahead and get rid of the add function and just distill it to its essence, which is not to add anymore, but let's just do division. I want to print out this time maybe x divided by y. So here we go. X divided by y is a nice simple program in my calculator. Let me do make calculator again, /calculator, and let's divide something like 1 divided by 3, which should, okay, weird. It gave me 0 instead of probably 0.333333, as you might have expected, for 1/3. So what might the takeaway there be? Why am I seeing 0, perhaps? Yeah? Yeah, so 0 is an integer, and indeed, that's what I'm telling the thing to print. And in fact, if we go over to my little cheat sheet here of format codes, I'm currently using the thing to print, and yeah, so 0 is an integer, and indeed, that's what I'm telling the thing to print. And in fact, if we go over to my little cheat sheet here of format codes, I'm currently using %I. I should actually, when I do division of numbers that might have floating point values, a decimal point that floats left to right, otherwise known as a real number, I want to use floating point. I should actually, when I do division of numbers that might have floating point values, a decimal point that floats left to right, otherwise known as a real number, I want to use %F for float instead. So I'm actually going to go back to my code here, and let's try this. %F instead of %I, and let me go ahead and make calculator. All right. Well, this didn't work then. Format specifies type double, but the argument has type int. All right, so that too is not quite working. So I think I actually need to make a change here further. Let me actually go ahead and do this. It turns out that besides integers, there are these things called floats and also doubles. A float uses 32 bits, and a double uses 64 bits. And that doesn't necessarily mean you can count higher as much as it means you can have more numbers after the decimal point. So if you want a more precise value, you throw memory at it by using a double and 64 bits instead of a float. But we'll keep it simple, and let me go ahead and memory at it by using more numbers after the decimal point. So if you want a more precise value, you throw memory at it by using a double and after the decimal point, and that floats. And also ahead and do this. It turns out that besides integers, there are these things called floats and also doubles. A float uses 32 bits, and a double uses 64 bits. And that doesn't necessarily mean you can count higher as much as it means you can have more numbers after the decimal point. So if you want a more precise value, you throw memory at it by using a double and 64 bits instead of a float. But we'll keep it simple, and let me go ahead and do this. Let me just do the math using the type of variable that I should be here. Let me do not int, but float z equals x divided by y. And now let me go ahead and print out the value of z. Strictly speaking, I don't need the variable, but I'm trying to be pedantic. And actually use a float explicitly this time. So we see a real number. I'm trying to be pedantic. And now let me go ahead and print out the value of z. Strictly speaking, I don't need the variable, but I'm trying to be pedantic and actually use a float explicitly this time. So we see a real number. All right, let me go ahead and do make calculator. So we see a real number. All right, let me go ahead and do make calculator. /calculator. 1 divided by 3. Make use a float explicitly this time. So we see a real number. All right, let me go ahead and print out the value of z. Strictly speaking, I don't need the variable, but I'm trying to be pedantic and actually use a float explicitly this time, so we see a real number. All right, let me go ahead and do make calculator. Dot slash calculator. Calculator, 1 divided by 3 equals explicitly this time, so we see a real number. All right, let me go ahead and do make calculator explicitly. Strictly speaking, I don't need the variable, but I'm trying to be pedantic and actually use a float explicitly this time, so we see a real number. All right, let me go ahead and do make calculator. Dot slash calculator, 1 divided by 3 equals, damn, now it's just showing me more zeros, which clearly isn't the case. Well, this is because of an issue that we'll generally call truncation. So truncation is just a term of art that means if you take an integer and you divide it by an integer, even if you get a fractional value, the fraction just gets thrown away because you're only doing integer-based math. So if there's anything after the decimal point, it just gets truncated, literally discarded. So what should 1 divided by 3 be? Obviously 0.33333333 ad nauseum. Unfortunately, you throw away everything after the decimal point, which leaves you still with just 0. And even though I'm seeing more zeros, that's because we threw away all of the 3s. That is just what happens when you use integers and do any kind of division like that. But there is a solution. We can actually convert or cast integers to floating point values. We can tell C, I know this is an integer now, but go ahead and treat it as though it has a decimal point, even if it's 0.0 at the end of the number. So I can go into this, and I can use parentheses and literally write float in parentheses. And over here for y, I can literally use parentheses and convert y to a float. The term of art here is type casting. You're converting one type to another effectively, or technically treating one type as though it's another, even if it doesn't necessarily have a mathematical impact. But what it means now is that z will be defined by dividing one float by another, so truncation will not now happen. So let me do make calculator, dot slash calculator, and now 1 divided by 3, there it is. Now the math is actually correct. But my God, we had to sort of jump through hoops just to get this to work. So to be clear, the issue we encountered was truncation. If you divide an int by an int, you will get an int, no matter what it should be mathematically. But if you instead typecast the values, the variables, to a floating point value, or a double for that matter, then a float divided by a float will give you a float and preserve all of those 3s. But here's another catch, or at least a limitation potentially with computers. What if I go ahead here and let me do this. Let me show you one trick here, even though the syntax is a bit weird. Instead of printing out %f alone, let me print out % dot maybe 5. Let me print syntax is a bit weird. Instead of printing out this, let me show you one. I go ahead here, catch, or at least a limitation potentially with computers. What if I go ahead here and let me do this. Let me show you one trick here, even though the syntax is a bit weird. Instead of printing out %f alone, let me print out % dot maybe 5f. So this is weird syntax, and it's only specific to printf. %.5f means show me 5 decimal places specifically. So if I do make calculator, dot slash calculator, one, 3, voila, I get 5 decimal places. If I want 6, let's do this. I'll change the code to 6, make calculator, Calculator, 1, 3, and now I get 6 threes instead. All right, well, wouldn't it be nice to be even more precise? Let's give me 20 significant digits after the decimal point. So make calculator, calculator, 1 divided by 3, and woof. So your middle school teacher seems to have lied to you at this point. 1 divided by 3 is apparently not 0.33333 with a line over it, or me 5x, and it's f. So you one trick ahead. Here's another flow to. It will be defined by do make. Now the math is actually correct. But my God, we had to sort of jump through hoops. F1 1 divided by 3 is apparently not 0.3. 33333 with a line over it, or just infinite number of threes. Okay, that's not quite 3 point. 1 divided by 3 number of threes. Okay, that's not quite the right conclusion though. Oops. Why might I be seeing these weird numbers instead of just lots of threes intuitively? Why this rounding error? Yeah. Exactly. The computer only has limited memory, finite memory, so it just can't represent every possible number in the universe, because we know from grade school there are infinitely many of those numbers. So what you're essentially seeing is the closest it can actually get. It's rounding to the nearest floating point value, if you will. And it also relates to how the numbers themselves are represented in memory underneath the hood. I can do a little better, though. Let me zoom out and let me upgrade, so to speak, in memory underneath the hood. I can do a little better.
5, 6, 7, 8, 9, 10, 14, 15, 16, 20.
Better, though. Let me zoom out and let me upgrade, so to speak, in nearest. Seeing is the closest it can actually get. It's rounding to the nearest floating point value, if you will. And it also relates to how the numbers themselves are represented in memory underneath the hood. I can do a little better though. Let me zoom out and let me upgrade, so to speak, from 32 bits to 64 bits and use doubles instead. I can still use %f. There's not a percent, you don't use %d for double. Let me do make calculator again, calculator, 1, 3. I get more threes, but still some rounding. It's more precise, but it's not 100% accurate, because that's just not going to be possible in terms of the computer's memory. So this is a whole other issue known as floating point imprecision, which is another type of limitation. We saw integer overflow. If integers can only count so high before you sort of run out of bits and things wrap around, floating point imprecision means that you can't possibly represent the infinite number of real numbers that exist in the universe if you only have a finite amount of memory. You would need an infinite number of bits, it would seem. So these are two issues that actually fundamentally can influence the correctness not only of your code, but code in the real world. And case in point, back in my day, I graduated in 1999, and a lot of the world thought the world was going to end around then, because around the time the years rolled over from 1999 to 2000, there was a lot of old software still running in the world. And in fact, that old software, reasonably so, only used 2 digits to represent years. Why? Memory was very expensive early on, and if you could use half as much memory to store a year, that was a win. That saved you money, that saved you memory. The problem, though, of course, is that a lot of old software from the 70s and prior was still running in 1999, and unless companies or individuals updated that software, 1999 might be mistaken for the year 1900 instead of 2000. It might be 1990, course, is that a lot of old that saved you money, that saved you memory. The problem, though, of course, is that a lot of old software from the 70s and prior was still running in 1999, and unless companies or individuals updated that software, 1999 might be mistaken. And unless companies or individuals updated that software, 1999 might be mistaken for the year 1900 instead of 2000, because all of the code just assumed that, of course, we're talking about the 1900s. This code's not going to be running 50 years later, but it was still in that case. So people had to scramble, and they essentially had to solve this by using more digits. So upgrading from a scramble was still running. Problem, though, of course, here, that was a win. That saved you money, that saved you memory. The problem, though, of course, is that a lot of old software from the 70s and prior was still running in 1999, and unless companies or individuals updated that software, 1999 might be mistaken for the year 1900. Instead of 2000. Because all of the code just for companies are from the money on, so software is still running in the world. And in fact, the world was going to end around then, because around the time the years rolled over from 1999 to 2000, there was a lot of old software still running in the world. And in fact, that old software, reasonably so, only used 2 digits to represent years. Why? Memory was very expensive early on, and if you could use half as much memory to store a year, that was a win. That saved you money, that saved you memory. The problem, though, of course, is that a lot of old software from the 70s and prior was still running in 1999, and unless companies or individuals updated that around the time influenced the correctness not only of your, a lot of the world thought the world was going to end around then, because around the time the years rolled. And in fact, that old software, reasonably so, only used 2 digits to represent years. Why? Memory was very expensive early on, and if you could use half as much memory to store a course, is that a lot of old software from the 70s and prior was still running in 1999, and unless companies or individuals updated that software, 1999 might be mistaken for the year 1900 instead of 2000, because all of the code just assumed that, of course, we're talking about the 1900s. This code's not going to be running 50 years later, but it was still in that case. So people had to scramble, and they essentially had to solve this by using more digits, so upgrading from 2 to 4. Nowadays, and really since the 70s too, we've used 32-bit integers to keep track of time, specifically keeping track of the number of seconds using an integer from January 1st, 1970, the so-called epoch, whereby that's just an arbitrary date early on where we just started counting time. So all of the clocks in your Macs, PCs, and phones pretty much just have a single integer that gets updated every second, but it's just keeping track not of absolute time per se, but how many seconds have passed since January 1st, 1970, just because that's the date humans chose. The problem is you can only count as high as 4 billion, give or take, with 32 bits, and actually 2 billion, give or take, if you support negative numbers as well. And the problem with that is that we're about to trip over the same issue again in not too long from now. This is the 2038 problem, because in the year 2038, on that date, mark my words, things could break again. Why? Because that 32-bit value is going to accidentally wrap around back to a 0 or a negative value, so we're going to go through the whole darn process again. Now, thankfully, the solution, as you might expect, is kind of just to kick the can even further down the road and use 64 bits, which I think will get us another 290 million years of runway. It's more than twice, so it's not our problem anymore at that point, but that's fundamentally going to be the solution, but it will still be finite. So we're just deferring to our descendants to actually deal with the issue some millions of years from now, if these things are still running. So if that does happen, here's the specific date that in 2038, all of a sudden our clocks will still think, because a negative number will get subtracted to the current epoch time. So we'll think we're back in 1901. So this has had some fun and very real-world implications. So for instance, this is the game Pac-Man, which you might have played. It kind of came out around my day back in time. And if you get to the 256th level, this unfortunately is what happens, because they didn't really expect that players would spend all this much time playing Pac-Man apparently, and they didn't really have a condition saying you win if you get to the 255th or 266th level. And so what happens here essentially is that the whole screen gets very garbled, because there's an integer in the original Pac-Man that counts to 256, but that's too big, so it wraps back around to 0, and it doesn't sort of know when to stop printing fruits on the screen, as in this case, to collect. Another example of this is actually from the original Donkey Kong game, which looks something like this in my day too, whereby in Donkey Kong, there was this mathematical formula whereby the number of seconds you have to solve the game was a function of 10 times your current level number plus the number 4. That dictated how many seconds you get. So of course, the higher the level, you get more and more time as the level climbs. Unfortunately, once you hit level 22, the math ends up being 10 times 22 plus 4, which gives you the number 260. And they too were using 8-bit values, a single byte to represent numbers, which means 260 is bigger than 256. And the way that math worked out was, well, 260 minus 256, if it wraps back around, gave people 4 seconds to solve level 22, which is just impossible. Gave people 4 seconds to solve level 22, which is just impossible. Like Mario can't even get up a couple of levels or so from where he actually was. So that too was sort of a well-known bug as well, since that works out to be there. Lastly, and this one is all the more real, in 2015, Boeing 787 was documented as having not a hardware bug, but a software bug in the following sense. A Model 787 airplane that has been powered continuously for 248 days can lose all of its power due to the control units simultaneously going into fail-safe mode. This condition was caused by a software counter that will overflow after 248 days of continuous power. Boeing at the time was in the process of developing a CPU software upgrade that will remedy the unsafe condition. And people did the math. It turns out that Boeing was probably using an integer that was 32 bits, and they were keeping track of time not in seconds, but hundredths of seconds. Because if you do out the math, after a 32-bit value has reached 4 billion or 2 billion 100ths of a second, the number wraps around back to 0, or negative 2 billion. And the implications was literally the plane wraps around back to 0, or negative 2 billion. And the implications, the number wraps around back to 0. And after a 32-bit value has reached 4 billion or 2 billion 100ths of a second, the number wraps around back to 0, or negative 2. 2 billion. And the implications was literally the plane's power would stop. And if you can believe it, if you grew up with Windows, Mac OS, or whatnot, anyone want to conjecture what the solution was until Boeing updated their software? Turn the plane off and turn it back on, because that has the effect of resetting its memory and therefore all of its variables back to zero. So this is ultimately to say, as you dive into problem set 1, you're first in C, you too will make quite a few mistakes when it comes to correctness. You too will encounter opportunities for better design and better style. In the real world, there are very much these issues. So even if you struggle, know that for better or for worse, you're in very good company. But some 3 months from now, you will be in much better shape, because this was week 1, and this is but very much these issues. So even if you struggle, know that for better or for worse, you're in very good company. But some 3 months from now, you will be in much better shape, because this was week 1, and this is CS50.
Cool. Well, I'm gonna go to sleep now. Alright, bye.